We are the 2024 Sensor O3 Detecting Activity and Confusing Visual Background team. We are part of Humane Interface Design Enterprise, which is affiliated with the College of Computing Department, and we're sponsored by Systems Engineering Research Center, also known as SERC.
The main objective for our group was anomaly detection, in particular in confusing visual backgrounds. So we were to develop a portable device that analyzes video feeds in real time to determine points of interest and detect certain unusual activities. This basically decreases the need of humans in different surveillance processes, allowing AI to detect suspicious activity in different environments and settings.
All right, going into this, we had a couple of objectives. Main one is we wanted a compact and portable system that we can deploy anywhere fast. We want a real-time monitoring system so that all the video that's being analyzed by the AI is live and up to date. We want pre-trained CV models because we don't want to start from the ground up. We just want to fine-tune them and get them to detect specifically what we want. And we want an optimized design so that we don't have to have a massive power source somewhere that we're bringing along with our device.
So in the design process, we created a system model, and there's two main components here, the on-site and the remote. The on-site will act as the on-site capture device that will capture the video feed with a 1080p resolution and the desired 30 frames per second rate. And this is going to be transmitted over a Flask web server to our remote computer workstation, where the human operator can see the live feed, which is being processed by the AI in real time.
After generating diagrams, we began completing some UI mockup. So here's the very bare bones initial mockup we came up with, and based on that, we developed it a little further, and that's what we based our final product on. So we're going to show you 3 videos that'll show our AI model in action. The first one will be at detecting people in crowds. Okay. This video will display a more real usage case for our model. This one will also show a real-life usage case of it detecting someone committing arson.
Before we show you our final product of the actual software, we're going to take a look at some of the controls that it offers. On your left, you're going to see the detection settings as well as alert preferences. You can control the confidence threshold of the YOLO V8 model, which is our machine learning model that actually detects the objects, as well as an overlap threshold to allow for customizability of the software. Alert preferences, there are 4 distinct alert types, including fire, gun, knife, and person. You can enable or disable them as you wish. And then on the right, you're going to see the AI model selection, which allows you to select different trained models to use.
So this is the final product. It's meant to run with a live stream, but we just took screenshots of a live stream. So you can see that right here, we just held up a picture of a gun to the camera, and then it was 93.1% confident that it was a gun. It sent the alert, and then it also logged it. And then you can see this also happening with a knife. And you can see these are in 2 different UI modes, full screen and minimized.
So for our conclusion and next steps, we successfully incorporated a threat detection model that can determine anomalies based on its surroundings, which has use cases in large groups of people loitering or someone with a weapon in an urban environment, which could be seen as a threat. We also fine-tuned the object detection model to meet our accuracy requirements for each class, which was around 90% mean average precision for each class. And our next steps in the future, we want to further train the model with new classes such as detecting suspicious movements and situations rather than just a person.
All right, we want to give big thanks to our sponsor, Captain William Shepard, and our faculty advisor, Dr. Robert Pestel.